Hi everybody, this is Mr. Folly, and welcome to podcast 1.2, where we're going to talk about isotopic notation, average atomic mass, cations and anions, and make sure you get a calculator and a periodic table. So hopefully you got one of those in class. If not, print it from the Canvas page right now. So let's go ahead and get started. I better remember this. Okay, some of you haven't seen this before. There are electrons, protons, and neutrons. These are the parts of the atom. Okay. The picture that you've seen is something like this for the atom. This is the Bohr model, and it's not quite perfect. But these are levels instead of rings. But this is the nucleus, right? And the protons, and the neutrons, and the nucleus. Now, what it really looks like are weird shapes of clouds. So there's still a nucleus and then there's a cloud of electrons. An electron sounds kind of evil and it's -1. A proton, positive, that's kind of +1. And a neutron is neutral, 0. The location is the electron cloud around the nucleus. That's why I do the cloud instead of the rings. Nucleus. So notice this has a mass of 1, and negligible. I'm going to spell negligible. Okay, so negligible isn't quite 0, but it's so small it doesn't matter. So that's kind of like anything that, Jacob says. Did Jacob talk? Yes, Jacob talks all the time. But what he says is negligible. If you didn't pay much attention to it, you're okay. Okay, so what does this mean? We're going to see symbols that look like this. This top number is going to be the mass. The mass is protons plus neutrons. This right here is just called the symbol. And this right here has a number of different things. It's really the same thing. It's the number of protons. It's called the atomic number. It's also sometimes called Z. Okay? So if you see a periodic table like this, the whole number is the number of protons. That's always going to be a whole number. This is a little bit different. This is your average atomic mass. So this right here is a single atom. Okay? So this could be Ariana is one person. This would be all the people at Lyons Township High School South. Okay? This would be 1. On the scale of, the average is 32.06. Ariana's a little less than average. Sorry. Maybe you can do better. Cations and anions. Ions, anything that's an ion means it has a charge. So if you're an ion, you have a charge. So a cation is a positive ion. Positively charged. An anion is a negatively charged. Now the way you change charge, get back. The way you change charge is by losing electrons to become positive. If you lose negative electrons, you become positive. If you're a negatively charged anion, you add electrons. Okay? Now the way I remember this is cats have paws. So if here's my picture of my cat, cats have paws, right? And claws for that matter. And here's my little kitty cat. Oh wow, this is getting bad. Okay. But cats have paws. So cations are positive. And electrons change in ions. How many protons, neutrons, and electrons are in chromium 52? I just realized as much as I advertised you to get your periodic table, I didn't get mine, so I'm getting mine out of my assignment notebook. Yeah, I hope it's still in here. So chromium, baby, here it is. Yes. So, chromium 52. So I'm going to look for chromium on the periodic table. Chromium is in the middle somewhere. Chromium is number 24. So when I look at the periodic table, chromium, I see chromium 52.00, and I see 24 up in the corner. So So how many protons? This number, the whole number, is going to be 24. So protons equals 24. Electrons equal protons. So electrons equal protons unless there's a charge. I hope you're writing that stuff down. And then I have neutrons. Okay, this right here is the mass. Okay, so if I have a word dash something, that's the mass. So this is chromium with a mass of 52. This is chromium with a mass of 50. So they can have different masses. Okay, so remember, mass equals protons plus neutrons. So if I have chromium 52, I know its mass is 52 equals, oh, get back here. 52 equals protons, 24, oh, get back here. 24 plus n. Oh, man. 24 plus n, and then I solve for n, right? So 52 minus 24 is 28. So this would be neutrons. That's my answer for that. Now notice chromium's going to be the same if it's chromium 50. Chromium will still have 24 protons. Why? Because chromium, all chromiums have 24 protons. Okay? And then the electrons, it doesn't have a charge. It's 24, but my neutrons will change. This is 0. So if mass is protons plus neutrons, my mass here is 50 equals 24 plus n. Well, in that case, it's a little bit, let me figure that out, that's 26. So the only difference between these two is how much they weigh, which means how many neutrons they have. Okay? Potassium ion, now I have to tell you right now, we'll figure it out later. Potassium ion is K positive. Whoa! Oh, K positive. Okay? So if I'm looking at potassium's, if I look at the box for potassium, whoops, come back. On my box it says 19, and then it says 39.10. Whoops, 39.10. So potassium's protons is that whole number equals 19. Now, because it's potassium ion, it's plus 1. So if it's plus 1, does that mean I have more electrons or fewer electrons? Well, protons are positive and electrons are negative. So for the positive one, I must have more positives. And if it's plus 1, I have one more positive. So I have 18 electrons. Where did that go? That's really weird. So my protons, let's write that down again, 19 electrons equal 18. And then my neutrons, if you remember mass, right? Protons plus neutrons equals mass. So 40 minus 19 equals 21, and that's my neutrons. Okay. Chloride is my last one. Now notice chloride isn't quite the same as chlorine. And chloride, and I have to tell you this right now, the chloride is Cl negative 1. Wow, is it weird how that disappears and comes back? Chloride is negative 1. So I'm going to look at chlorine first. So if something ends in "ide," you're going to look for the "ine" for the protons. Chlorine has 17 protons, just like before. Now if it's negative 1, it will have negative things have more negatives than positives, right? So it have to have 18 electrons. And 36 is its mass, and mass is protons plus neutrons, right? So if mass is protons plus neutrons, then we have 36 minus 17, and that means I would have 19 neutrons. So neutrons change in isotopes because neutrons change the mass. Alright. Now, I don't know why these things are showing up here, but that's it. How many protons, neutrons, electrons are in here? Okay. So, this down here is my number of protons. Protons are 2. This down here is my number of protons. Protons are 8. Okay. Electrons, remember, if I don't have a charge, get back here. If I don't have a charge, it's the same. Electrons are 2. I have a charge. Electrons are not the same. So if it's positive, I have more protons than electrons. Got it. This top number is the mass. Right? I'll go ahead and write mass equals 6. So remember, mass equals 6, and that means 6 minus 2 equals neutrons. Okay? And neutrons equal 4. My mass is this top number. This is the mass again. So 16 minus 8 is 8. Okay? Why don't we need a bottom number? This number 8, if I looked on the periodic table, if I looked at atomic number 8, whole number 8, that's oxygen. This symbol tells me the number of protons if I have a periodic table. And you should always have a periodic table. If no indication of a charge is made, the substance is a neutral atom. That's what it's called. Oh, you know, I'm going to add something right here. Protons determine identity. And we already heard this one right again. Electrons determine charge, and neutrons determine mass and nuclear stability. And that's buried in there, but I want that to be super clear for you guys. Okay, don't write all this stuff down. I hope you didn't pause it and write all it down. So where does the mass in the periodic table come from? So this is just a concept thing, and you just have to be able to apply it. Where does the mass from the PT periodic table come from? Scientists chose 12. They needed to choose something to have a mass of 12.000000 forever. This determined the mass of the neutron and the proton. Now, protons and neutrons are very close in mass, but they're not identical. We average every atom of each isotope to get the average atomic mass. To make life easy, we say a proton neutron weighs 1 AMU, so we round it a little bit. Okay? So basically, they took a big sample and found an average mass. Okay? And it's all based on carbon-12 and 12. There are 3 isotopes of hydrogen. Again, this is just no righty-righty. Now, notice the average mass of hydrogen is 1.00794, but there are 3 isotopes, 1, 2, and 3. Wouldn't I add up 1 plus 2 plus 3, and that would give me 6. 6 divided by 3 would be 2, but its average mass isn't 2. So why isn't the average mass of hydrogen equal to 2? This must be 99% of it. And this must be, I don't know, 0.9% of it. And this must be 0.1% of it, or something like that. See how that would make the average be really, really, really close to 1? Okay? Now I estimated those, but we will look closer at how that works. So this means this is the average. You do need this. Yes, write this down. Woo. Oh, I guess that would be a sad face if I write it down. How many carbon atoms weigh 12.01? That's the average mass in the periodic table. None! Because that's the average. So if I said the average in the class right now is an 87.3821352. Well, we only have one assignment, which is to turn in your form, so that means that it's impossible. How many people have that average? No. How likely is it that if I grab one boron atom, it will weigh 10.8? Now notice 10.8 on the periodic table is the average atomic mass, 0%. That average is not the mass of any particular isotope. Okay. So this is how we do average atomic mass. Okay. Naturally occurring europium consists of 2 isotopes with mass of 151 and 153. Europium 151 has an abundance of 48.03, and 153 has an abundance of 51.97%. That's atomic mass. So what we're going to do is we're going to do mass 1, percentage 1, plus mass 2, percentage 2, plus mass 3, percentage 3, ... equals average mass. Okay? So, notice in this case I only have 2. So I'm just going to plug it in. So what's the mass of my first isotope? Well, here's 151. That's 48.03. 151. And I'm going to use the decimal form of it. 0.4803 plus the other one weighs 153, and its percentage is 0.5. Oh, get back here. 0.5. Get back here. No, you're going forward, not backwards. 0.5197 equals. Okay, now notice if I multiply it by a bigger percentage, the number's going to be bigger, right? It's going to have a bigger impact on it. So let's do this. 151 times 0.4803 equals plus quantity 153 times 0.5197 and quantity equals 152. The average atomic mass, we're going to call it an AMU. Okay. Does it work? Another format I can give it to you. Here's two isotopes. There's their masses. There's their abundances. Let's do it. So again, remember, mass 1, percentage 1, plus mass 2, percentage 2, equals average mass 1. Now notice they give you a little bit more specific masses here. 23.985. Again, my percentages. Now notice they gave me the decimal form already, so I don't have to change that. 0.78. Oh, get back there. But it's exciting to see where it gives you 0.7870 plus 25 point. Oh, we'll get back here. 983. Percentage 2 is 0.2130 equals. Calculators assemble. Oh, that's nice. Man, is that illegible. Okay, so that's 20. Ooh. Why did I say 29.985? I miswrote that. Did you notice that? 23.985 times 0.787 equals plus quantity 25.983 times 0.2130 equals, and my battery just died. If you hit on enough, it comes back on. 23.985 times 0.7870 plus 25.983 times 0.2130. Oh, it's dead. Your calculator can tell you that answer. Mine just died. But that's it. And then let's take a lookie. Review. Isotope notation and standard notation can tell you the number of protons, neutrons, and electrons. Average atomic mass includes the abundance of elements. That is all. Toodles. Let me end.